Hello and welcome to Power System Analysis 2. We are in module 3.4. In this module, we'll talk about a unit commitment. Okay, now let us check what commitment is. So, optimal unit commitment, UC, unit commitment in short. So, what does it mean? Before that, you need to understand that it is not economical to run all the machines, all the generators all the time. When the load is low, you need to switch some of them off and switch on some others. Okay, so the unit commitment is that you needed to know that which generator should be turned off and which should be turned on. Okay, which unit should be committed to a particular load. So to determine the units of the plant that should operate for a particular load is a problem of unit commitment. So so this is the definition, but it is helpful for thermal plants, but hydro plants it is not that helpful. Okay, now in the unit commitment method there is something called a dynamic programming method. In the dynamic programming method, it's a straightforward method. Okay, so it is used if the load is assumed to increase in small but finite size steps. Dynamic programming can be used to advantage for computing the UC or unit commitment table. That means if the load increases to a very small amount, we can use the dynamic program to find out the UC chart. UC chart is what? It tells you the unit commitment chart that if this is a load, this generator should be turned off, this should be turned on, this should be turned off, this should be turned on. So you can have a chart and the operator can see. He need not do the calculation. Calculation is what you are doing for the operator, and you are making a chart. So you are the supervisor of any kind of a generating station, and you are providing this chart to the operators. Okay, and it is not necessary to solve the coordination equation. So remember, what is the coordination equation? The lambda equation. Okay, so that equation we need not solve here. It is that directly you can solve. Okay, so what is the assumption here is that the total number of units available, their individual cost characteristic, and the load cycle of the station are assumed to be known at priori. That means we know what is the load going to be. We know what is the cost characteristic of all the generators. Okay, and the type of load cycle. So if all these things are known, then this method is applicable, or else the method may not be applicable. Further, it shall be assumed that the load on each unit of combination of unit changes suitably small unit step sizes. So the load is also changing with a very small unit step sizes. It do not change rapidly. Okay, so is it a bad assumption? No, because in our general cases the load changes very slowly. Okay, but if the load changes to a very fast value, then some other method is used. So where is unit commitment is applicable for this from the morning to the evening period, when the amount of power is required. Okay, but from the evening to night there will be a sharp fall in the load. So you cannot apply unit commitment or dynamic programming method there. Okay, now let us describe dynamic programming method. It is a bit complicated, but you need to go on slowly with me. So I am taking this paragraph from the dynamic programming method. So we starting arbitrarily with any two method. The most economical combination is determined for all the discrete load levels of the combined output of two units. Okay, so you have a combined so you have, let's say, n number of units. So you pick any two units. Okay, and after the after these when you pick the 2 units, you see whether which one would be an economical combination, okay, to meet all the discrete load levels. That means you have a load level, let's say load level of 90 to 100. So you check for 90, 91, 92. So you are using discrete load values, okay, not continuous like 99.90.001, 90.002, like, but rather than you are taking discrete points 90, 91, 92 to 100. So for these points you need the economical combination of these two generators, okay. The most economical cost curve in discrete form for 2 units are thus obtained. So you can say that for this amount of load, this combination of the generators are this cost curve is better. This cost curve you can follow. Okay. Now the third unit is now added, and then the procedure is repeated to find the cost curve of the third combined unit. It may be noted here that the operating combination of the third and the first, and also the third and the seconds, are not required to be worked out, resulting in considerable saving of computational effort. The process is repeated till all available units are exhausted. The advantage of this approach is that, having obtained the optimal way of loading key units, it is quite easy to determine the optimal manner of loading k plus 1 unit. So basically, what in the dynamic programming method, we are let's say we have n number of generators, we take any two, okay, and for a given load range, or so we have let's say a load range of 90 megawatt to 100 megawatt. So for 90 to 100 we take discrete points of 90, 91 to 100, and we check for every point a particular combination of these two generation for economic operation. So we get the total incremental cost of these two generators. Now after this is done, we include one more, okay, and these two generators now is considered to be a single unit, okay. Now again that generator, the new generator, and this combined unit is now checked for all these different load points, and this goes on after the other, okay, till all the units are exhausted. So this is basically the dynamic programming method, okay. Now let us go for the mathematical consideration of the dynamic programming. Now before that, you need to understand this. There is something called a cost function fn of x. What it is defined as it is the minimum cost in rupees per hour in generating x megawatt by n units. So if I tell you f10 of 20, that means you are telling me f10 of 20 is nothing but it is the minimum cost for generating 20 megawatt using 10 generators, okay. Now there is one more thing, it's called small f n of y. Small f is the cost of generating y megawatt by nth unit. So here small f of n y means, like if I say small f 1 of 2, that means it is the cost of generating 2 megawatt by unit 1. If I say small f 1 comma 20, that means cost of generating 20 megawatt by unit 1. Okay, and capital F is actually the minimum cost, but small f is cost of generation. Okay, so let us say we are considering we have seen one combination, and we have found the minimum cost. Okay, so the minimum cost we have found out for let's say there are total n number of generators. In this dynamic programming method, we have found till n minus 1 number of generators the cost function is obtained. We need to find the last combination. Now how we do it is that we do fn minus 1, that is the minimum cost with n minus 1 generators, and what is the amount of power to be produced? X minus y, because the last generator is producing y amount of power. So fn minus 1 of x minus y is the minimum cost of generating x minus y megawatt of power by remaining n minus 1 unit. Now using this combination, we need to find out again a minimum cost when the fn minus 1 and small f n is working together. So we find out the total cost function as the fn of x is equal to minimum of fn small fn y and fn minus 1 of x minus y. Okay, I think you have getting the this clear. Okay, now let us check this dynamic programming method. Okay, the use of dynamic programming method, or DP, is solving unit commitment problem is illustrated by means of an example. So this is the example that they have given. Consider a sample system having 4 thermal generating units. So you have unit 1, 2, 3 and 4. Okay, and parameter listed in 7.2 is required to determine the most economical unit to be committed for a load of 9 megawatt, and let the load change be in step of 1 megawatt. Okay, so the load goes from 1 megawatt, 2 megawatt, 3 megawatt, 4 megawatt to 9 megawatt. Okay, so what we have, if I have the 4 generators with the maximum and minimum generation capacity, and we have the cost curve A and B, cost curve constants A and B are given, and D is parameter D is taken to be 0. Okay, so you can see that we start with the first cost function, minimum cost function. So for fx, so f1, small f1 means we take generator number 1 producing a power of x. So small f1 x is the first generator producing a power x. We take it as capital F1 of x, because we are starting with that will be the minimum. Okay, now let us check for f1 of 9. That is capital F1 of 9 is nothing but f1 of 9. Now we put the value of 9 in the previous equation taken from the table. We are taking unit 1, so 0.77. Okay, so half into 0.77 into 9 square and 23.5 into 9, so you'll get 242.685 per hour. Okay, so from the same parameter we can have the computation of the minimum cost function of 2 generators, that is given as capital F2 of 0, 1 to 9 values. Okay, so capital F of 1 combinations are done. Now capital F of 2 combination will be done. Now how to find the capital F of 2 combination? We have to check for all different combination of f of 1 and small f 2. Okay, so you can see in this equation, capital F of F2 of 9 is the minimum of all the combination of small f2 plus f of f1 of 9, small f2 1 of f1 of 8, small f2 2 of f1 of 7. So all these different combinations are done, and then you can get the capital F2 of 9. Okay, so this is the way of computing. So this is an illustration of how the combination of dynamic programming method is done. Okay, so after we find out the F2 of 9, so if this last line, the F2 of 9 is given like this, this is done by computer. You don't need to require to do this, but you need to understand how the process is done. Now when F2 of 9 is found, or capital F2 of 9, you need to find capital F2 of 8, F2 of 7 and F2 of 0. Okay, so F3 of 9, again it says that minimum of small f3 0 and f2 9, small f3 1, f2 8 and so on. Again the same procedure is completed for the next load point. Okay, so this is an example of dynamic programming method. Okay, with this I'll end this class. Just go to the slide and check whether you are getting the combinations or not. Okay, thank you.